All right, so this is day 5, the notes portion. It's review from what you did last year. You'll want your notes packet handy to be working through as we are doing this. So a review of polar coordinates. So polar coordinates are defined by a radius, comma, an angle in order to plot them. So you move the angle first, and then if the radius is positive, you move the same direction as that angle for the radius, but if it's negative, you go the opposite direction. So for example, let's say we had 3 comma pi over 3. So that's 60 degrees. So that would be, here's pi over 3, and wherever 3 would be on that, that would be our point, 3 comma pi over 3. But if we had a negative radius, 3 comma pi over 3, you would go to pi over 3, but it's on the ray that goes the opposite direction. So it's on the opposite ray. So the red point there would actually be negative 3 pi over 3. You go where the angle is, but then you go the opposite direction. So first thing we're going to do is we're just going to plot a couple points, make sure we got it down. So we're going to have a radius of 2. So you can imagine that there's a circle with radius 2. 3 pi over 4 is the same as 135. So 135 would be right there. Our second point, negative 5 pi over 2. So we're going to go over to pi over 2, which is right here, but we're negative 5, so we've got to go through to the other side. So note, negative 5 pi over 2 would actually be the same location as positive 5 comma 3 pi over 2. And in the first example, if we did like either 7 pi over 4 or negative pi over 4 and did a radius of negative 2, that would put us in the same location that we plotted as well. So because there are multiple coordinates that could represent the same spot, we're going to see if we could label this in a bunch of different ways. And we're actually going to list 4 of them. It says there are 3. So first off, let's say we maybe went around this direction. If that reference angle is pi over 6, that means that we went around 11 pi over 6. So our first possible coordinate, remember it's r comma theta, would be 11 pi over 6 for the angle, and we went out with a radius of 4. Well, now what if we had done that angle going backwards? We could have done an angle of negative pi over 6, and that would still be a radius of 4, because we would want it in the quadrant where we're located. Or we could do our ones on the opposite ray. So we could do our options for if we had a radius of negative 4. So this pi over 6 reference angle, if you had a pi over 6 reference angle here initially, that would be 5 pi over 6. So we could have 5 pi over 6 comma negative 4, because we would first go to the 5 pi over 6, then go through the opposite ray to get here. Or going positive 5 over 6 is the same as going negative 7 pi over 6. So that would take you to the second quadrant, and then it would send you through to the fourth quadrant because of the negative radius. Now, there's really an infinite number. We could take these points, and each of the angles, we could do plus or minus 2 pi to them, and they would put us in that same location. Okay, so converting polar coordinates to rectangular coordinates. So sine theta is equal to y over r. Because if you look at our triangle there, the opposite is y. The hypotenuse is the same as our radius, whatever that like circle is that we're on. So when you were with Mr. DeLands last year, he usually had you memorize y equals r sine theta. And likewise for cos theta is x over r. So if you get x by itself, that's equal x equals r cos theta. Now the other ones that you want to be comfortable with, if we did Pythagorean theorem with this triangle, we would have x squared plus y squared equals r squared. And if we worked with the angle, we could say that tan theta is equal to y over x, or in other words, theta would be equal to either tan inverse or arctan of y over x. So those are the essentially four formulas that you need to work with to convert back and forth. So we're going to convert this to rectangular form. So our x value is equal r cos theta. So x equals 4 cos of 2 pi over 3. And the y value will be r sine of theta. Well, 2 pi over 3 is the same as 120 degrees. So that's a 60-degree reference angle. If we label our special right triangle, x will really be 4 times cos of that 60-degree reference angle. So the cos of that 60-degree reference angle is negative a half. So our x value then is just negative 2. And sine from that 60-degree reference angle is just positive radical 3 over 2. So y for us would be 2 radical 3. Meaning our rectangular point would just be negative 2, comma, 2 radical 3. And if we think about that, so if we plotted 4 with a 120, so if this was like 4 with 120, that would be like about here. And if you went 2 to the left and up 2 radical 3, that seems reasonable that it would be there. So I would say always just at least think about and see if your answer makes sense in terms of quadrants. Both in second quadrant, so we're probably good. All right, so we're going to practice doing several of these going each direction, and you have a whole bunch of space on the bottom there with which we can do this. So first we want to switch that first one to rectangular coordinates. So x is equal to r cos r theta, and y is equal to r sine of theta. Well, cos of pi over 2 is just 0, so that would give us the x is 0. Sine of pi over 2 is just 1, so that would give us y equals 6. So therefore, our rectangular coordinate is just 0, comma 6. Why don't we jump down to the bottom and we'll do the other rectangular one. So we'll have, again, we're going to do the fourth one here. So we'll have x equals r cos of 4 pi over 3. Y is equal to r sine of 4 pi over 3. So 4 pi over 3 is 240, so that's a 60-degree reference angle in the third quadrant. So we'll have negative 1, negative square root of 3, and 2. So therefore our x is really 8 radical 3 times the cos of that, which is negative 1/2. So x will be negative 4 radical 3. And our y will be 8 radical 3 times the sine of that, which will be negative radical 3 over 2. So this is definitely going to give us a negative. The 8 divided by 2 is 4. The radical 3 times radical 3 is 3, and 4 times 3 will give us 12. So y will just be negative 12. So we get the rectangular point of negative 4 radical 3, comma, negative 12. And that would be in the third quadrant, and a 240 with a positive radius would also be in the third quadrant. All right, so now going from the rectangular to polar. So to start out, we want to find our radius, and we can do that with our x squared plus y squared equals r squared. So we'll have negative 2 squared plus 2 squared equals r squared. So this will end up giving us 8 equals r squared, or in other words, r is equal to plus and minus 2 radical 2. And the reason it's both, because remember, we're going to have multiple angles that we could just send through to the other side if need be. Now theta is equal to tan inverse, or arctan of y over x. So 2 over negative 2. Well, that's tan inverse of negative 1. That'll be a 45-degree reference angle, but in the fourth quadrant. Our quadrants for tan are either the fourth or the first. So theta is going to end up being negative pi over 4. So we got to think about rectangularly, negative 2 comma 2 would be in the second quadrant. So if we have an angle of negative pi over 4, that's going to put us in the fourth quadrant, meaning we're going to want to use that with the negative radius to put us back in the second quadrant. So we'll have negative 2 radical 2 comma negative pi over 4. Or we could have our positive 2 radical 2. And if you just went directly to the second quadrant with a pi over 4 reference angle, that would be 3 pi over 4. So the last one, we'll find our radius first. So we'll have 27 plus 9, so we'll have 36 equals r squared. So r is equal to plus and minus 6. So we know we'll have negative 6 comma something, or 6 comma something. We'll do our theta is equal to tan inverse of our y over x. So we'll have 3 over 3 radical 3. That's equal to tan inverse of 1 over radical 3. So the opposite is 1, and the adjacent is radical 3. So we should be working with a 30-degree reference angle. And because it's positive, we're in the first quadrant. 30 degrees in the first quadrant in radians would be pi over 6. Well, our rectangular point, okay, 3 radical 3 comma 3 is in that first quadrant. So when we're using the pi over 6, we want to make sure that's grouped with the positive radius so we stay in that first quadrant. Now the negative radius option would be if we came with a pi over 6 reference angle to the third quadrant. That's really 7 pi over 6. And then it would send it back to the first quadrant. All right, so if you could grab your calculator. So we're going to review graphing polar functions. So we'll want to go to a graphs page. On the graphs page, we've got to go to Menu, Graph Entry, Edit, and we want to go down to Polar. Our theta step, notice, goes from 0 to 2 pi, which is what we are our theta range, and our step is 0.13, so basically it'll do a bunch of points. And we're going to graph, as you see on your paper there, 3 sine 2 theta. Now we have to actually use theta. Theta's in with the pi. Okay, and if you hit enter, we get our graph for it. Well, we want to trace that. We want to know what gets plotted first. So if we do trace and graph trace, menu, trace, graph trace, notice we're starting out at 0, 0. And just hit the right arrow. So we are plotting in the first quadrant first, that first loop, and then we go, notice, to the fourth quadrant. Now let's think about why that would be. So when our angles were from 0 to pi over 2, the radius must have been positive, so we're in the first quadrant. But the next angle should be pi over 2 to pi. Think about why are we now in the fourth quadrant if we're really doing pi over 2 to pi? Well, it must mean that there is a negative radius. So if we keep going, we're approaching plugging in pi. So that would be pi. Well, now we're a little bit beyond pi, so we're from pi to 3 pi over 2. Notice we're in the third quadrant. So that must mean the radius is positive. So if you finish out at 3 pi over 2, now we go to the second quadrant. Okay, but our angle measures are really fourth quadrant angle measures. We're 3 pi over 2 to 2 pi, but that means our radius must be negative for that, and that's why it's sending it through to the other side. Okay, so the trace function can be helpful on the calculator, or you can just think about it with your different values to see where it is heading. Okay, so our graph, and I'll do my best to draw this. Probably won't all be exactly the same. Wasn't the best, wasn't the worst. Okay, but that's our graph roughly there. And our curve is complete when we go from 0 to 2 pi. Now sometimes it might not take a full 2 pi to complete the graph depending on what the equation looks like. On the bottom of that page, we just have a review of our formulas. We got the y, the x. Tan theta we know is y over x. So theta, that means, can be written as tan inverse or arctan of y over x. And again, that's all coming from that triangle there on the right. And we know x squared plus y squared is the same as r squared. So moving to the last page, we're just going to convert forms for some equations. So when you convert to polar form, you want your equation to be an r equals, and the only other variable you can have in it potentially is thetas. So we're going to use our formulas that we just saw on the previous page. Well, x squared plus y squared is the same as r squared. So that means that r has to equal either plus or minus 4. Now, this should be a circle. So the graph of r equals 4 and r equals negative 4, those are both saying plot every point where the radius is 4. So if you have a positive 4 radius, your graph would look like this, where those are all 4s. If you had a negative 4 radius, it's going to look the same, just it would actually start plotting this first, because as you start with first quadrant angles, it would send it through to the other side. So the final result is the same thing. So in reality, you can just have r equals 4, and those end results would be the same. All right, x we know is r cos theta plus 2 times r sine theta for the y equals 5. So this is technically in a polar form, but we like to get r by itself. So if you pull the r out, you get cos theta plus 2 sine theta equals 5. And we'll divide over, and this is just 5 over cos theta plus 2 sine theta. So we'll finish up at the bottom going from polar to rectangular. So when we're in rectangular, we should only have x's and y's as our variables, no r's or thetas. Well, we know that y is equal to r sine theta. So if we got sine theta by itself, we could write this as y over r. Well, if you multiply the r over, you get r squared equals y, and then r squared is just x squared plus y squared. So now you have an equation that only has x's and y's in it. That middle one on the bottom, secant, can be written as 1 over cos theta. If you multiply the cos theta over, we get r cos theta equals 1. And r cos theta is just the same as saying x. And the last one, theta equals pi over 4. Well, we know theta is the same as tan inverse. So we got tan inverse of y over x equals pi over 4. Well, if you do tan of both sides, that'll give us y over x equals tan of pi over 4. That's a 45-degree reference angle. 1, 1, radical 2. So tan is just 1. So we got y over x equals 1. Or in other words, y equals x. So in rectangular, that's y equals x. But in polar, that's theta equals pi over 4. Here's all the positive radii when you have pi over 4. There's all your negative radii when you have pi over 4. And that's why it's just a line. All right, and that's it for the review of polar functions from last year.